So in the last video, we discussed the fact that the slope of the demand curve is not the same thing as elasticity of the demand curve. They're related, but they're not the same. And we showed, as this graph shows, that elasticity in fact decreases as we move down and to the right along a demand curve. This becomes especially important when we think about one of the more useful uses of elasticity, which is in helping a firm determine how best to increase and maximize total revenue. So, what's the story here? Why is elasticity different at the top left of a demand curve than it is at the bottom right of the demand curve? In the last video, we discussed mathematically what was going on here. It's about percent changes and the fact that we calculate percent change relative to the midpoint, and so the midpoint is a higher number if we're up high on the price axis than it is if we're down low on the price axis. But more importantly, the story is, if you remember going all the way back to what are some of the things that determine elasticity, price elasticity of demand, one of the things that we discussed there was how much of your budget you're currently spending on an item, right? So you would expect that if an item is more expensive, so at the top left-hand corner of the demand curve, where the item is more expensive, people's demand for that item is more elastic. If lattes cost $5, no one wants one. But just a tiny decrease in price can make a big difference in how many people are coming through the door for a latte. So that's different. We can contrast that with what's happening down at the bottom right hand of a demand curve, where the lattes are already super cheap. They're only $1 down here, right? And so the same percent decrease in price is not going to have the same effect on bringing more customers in. Sure, it'll bring maybe some more customers in because that's the law of demand. When we lower the price, we increase the quantity demanded. But if the price was already super low, say 10% sale is not really that big a deal to folks. As if the price were really high and we offered a 10% sale, it's a much bigger deal. It's a bigger dollar amount, right? So that's kind of what's going on here. On the same demand curve for the same product, if we're up at the top of the demand curve where the price is high, we have highly elastic demand, versus down at the bottom where the price is low, we have highly inelastic demand. You could tell a similar story from the quantity perspective, that when you already have a bunch of them, so down here in the bottom right corner, we're already selling a bunch, relatively a bunch, then you don't necessarily run out to buy more of them just because there's a sale. You already have a lot. If you don't have very many, this is where a sale might change your behavior, because sure, I'd like to have one if I could afford it, right? Or something like that. So that's kind of the story of what's going on as we move along the demand curve and elasticity changes. So how does that affect our decision making as a firm? So if you're the person selling lattes, right, your goal is to maximize your profits. In order to maximize profit, you need to maximize revenue, right? You'll also want to decrease costs, but that's another side of the story that we'll get to a few chapters down the road. But let's think about the revenue side. So the revenue is the amount that a firm receives from the sale of goods and services. How much money comes across the counter toward you, right, in your direction if you're the seller. And we calculate revenue as price times quantity, right? You know this. If you ever had a lemonade stand as a kid or anything like that, at the end of the day, if you sold each cup of lemonade for a quarter, at the end of the day, how much money did you bring in? Well, it's 25 cents times however many cups you sold, right? So the price of the good times the quantity sold. Elasticity then is very related to total revenue because elasticity tells us about the relationship between these two things, the price and the quantity, right? And we know that when price goes up, quantity is going to go down. So there's good news. Yay, we're going to make more money per item that we sell, right? But then there's bad news. We'll sell fewer items, right? So elasticity is going to enter the story, helping us to know how changing our prices affects total revenue, right? So we know that there's an upward tug if we're increasing prices, for example. We know there's an upward tug here on our revenues, but there's a downward tug here on our revenues. So the question of what happens overall, does our revenue go up or does it go down, is answered by which tug is stronger, which is exactly the question that elasticity answers for us. When we raise the price, does quantity change more by a higher percent than the price changed or a lower percent than the price changed, right? So here are some numbers to sort of give us an example. Don't freak out. I know that's a lot of numbers on one page, but the good news is all those numbers means that someone else has done the math for you, right? So let's concentrate over here on the left-hand side. We've got a demand schedule, right? Price and quantity demanded. That's the first two columns here. And then we've calculated total revenue, which is just the price times the quantity. That's what's going on in this column here, right? And then moving to the right, we've calculated the percent change in price, the percent change in quantity, and the elasticity at each of these, between each of these. So if we go from 5 to 4, then from 4 to 3, etc. So if we move from $5 to $4, we notice that our revenue goes from 0 to 4. And this is an area where we have highly elastic demand. So notice the percent change in price is much smaller than the percent change in quantity demanded, right? So quantity was really responsive to a change in price at this point. If we keep lowering our price, then we increase our revenue from $4 to $6. Still have pretty elastic demand. We still have a smaller change in price than change in quantity. Change our price again from 3 to 2. Notice our revenue stays exactly the same. We changed our price down by 1. We increased our customers by 1. The revenue stays exactly the same. This is the point where we have unitary elasticity, where the change in price was exactly the same percentage as the change in quantity. What happens if we keep lowering our price? Now we're getting to an area where our demand is relatively inelastic, and lowering the price also lowers our revenue. If you're the seller of lattes, where do you want to be? Your sweet spot is right here at unitary elasticity, right? Your maximum revenue happens right here at unitary elasticity. What's the story? What's going on? So the story is that when demand is highly elastic or even relatively elastic, you benefit by lowering your price, because even though lowering your price is kind of bad news, it means you're getting less money for each item that you sell, the good news is you're bringing in more customers. You're gaining more by gaining customers than you lost by lowering the price, right? So overall, your revenue increases when you lower the price, as long as demand is elastic. Because when demand is elastic, it says you can lower your price a little bit and you get a huge response from the demand side. You'll get a lot more people in the door, right? On the other end of the spectrum, when demand is relatively inelastic, you help yourself, you increase your revenues by increasing the price. What's the story here? When demand is inelastic, so the example that we gave in a previous video was something like emergency medical care, right? You get into maybe ethical issues here, but the economic issue is that if demand is inelastic for the product or service that you're selling, then you can raise your price and you don't lose any customers, right? Or you don't lose many customers. You gain more by raising the price than you lose by losing customers, as long as demand is inelastic. Because inelastic means the quantity demanded is not very responsive to a change in price. And when that's the case, you want to increase your price because you won't lose very many customers if you do, and you'll bring in more money for everything that you sell, right? So if you're on the top end of your demand curve where demand is highly elastic or even relatively elastic, you want to lower your price and bring in more customers. That's how you'll increase your revenues, by increasing the quantity piece, right? If you're on the bottom end of your demand curve where demand is pretty inelastic, then you want to increase your price in order to increase your revenue, because the change in price going up is where you're going to increase your revenues, right? Where your goal, where you want to be, is somewhere around that unitary elastic point. So unitary elastic is where the change in price and the change in quantity demanded is exactly the same in terms of percentages, right? Not very likely that you'll hit that point where they're exactly the same in the real world. It's sort of a theoretical possibility. It's very hard to get to a point in reality where things are exact, right? But you always want to be sort of aiming for that point where the change in price and change in quantity are the same percentage. We can show this on a picture as well. So graphically, we'll show the trade-off when a firm changes the price of goods. So remember, if we increase the price, there's good news. We get a higher price per unit. And there's bad news. We sell fewer units. If we reduce the price, there's good news. We're going to sell more units. And there's bad news. We're going to receive a lower price per unit, right? So the question of what happens to our revenues, do revenues go up or do revenues go down, is a matter of, well, which is stronger, the good news or the bad news, right? So on the graph, back to our same latte graph. This is just a graph of the numbers that we saw on the table before. If we have a price of $4 per latte and we're currently selling one latte, right? So $4 we sell one. And we lower the price, right? What happens when we lower the price? Well, if you think of, so we're up here in the elastic region, right? If you think of revenue graphically, revenue is price times quantity, right? On this graph, our price is 4 and our quantity is 1. If you multiply 4 times 1, what you get is the area of this rectangle, right? If we lower the price to 3, then we'll increase our quantity to 2. And our revenue now becomes the area of this rectangle, right? It's 3 times 2. Length times width, or height times width. So what has happened when we decreased our price from 4 to 3 is we lost this square of revenue. We had this guy willing to pay $4, and we've lowered the price to 3. So this guy who would have given us $4 is now only giving us 3. We lost $1 off of him, right? but we pulled in a new customer, and so we gained $3 from pulling in a new customer. Overall, our revenue has increased because we lost less than we gained. Right? What if we keep going? If we lower the price from 3 to 2, then our revenue goes from this rectangle to this rectangle. We lose $2 from these first 2 customers who were willing to pay us 3, but we're only charging them 2. So we lost $1 from each of them. But we brought a new person in the door. We're charging $2 now, so we gained $2 from that new customer, right? Overall, we lose exactly the same amount that we gain. It's a wash. That's where we have unitary elastic demand, right? What if we keep going? Now we're in the inelastic region. If we continue to lower our price in the inelastic region, and we go from $2 to $1, then we'll go from 3 customers to 4 customers, right? What do we lose? We lose $1 off of each of those first 3 customers who would have paid us $2, but we're only charging $1 now. So we lose those $3 that we were making off of those 3 guys, but we bring 1 more customer in the door. However, we're only charging that customer $1, and so we only gain $1 where we lost 3. So in the inelastic region, we don't want to continue to lower our price because now we're losing more than we gain when we lower the price. Instead, we want to do the opposite. We want to go back up where we gain 3 and lose 1, right? So in the elastic region of our demand curve, up top, we want to lower the price and bring in more customers. That's how we increase revenue. In the inelastic region, we want to increase the price, even though it might mean we lose a few customers, because the gain from increasing the price is greater than the loss from losing a few customers. So this is how elasticity is related to revenue. And it's really a super useful tool to think about as you're playing around with prices if you're a business owner or a firm selling a product like Skinny Lattes.